Alright, let's see what's going on here today. So this will be, this seems wrong. Yeah, I just asked the AI, but I asked them again, and again, and again. This is 3 times. I didn't ask Copilot though yet, but I asked Copilot something else. I implemented the remarching. Oh yeah, there is a way for me to share my screen on my Android using VPN. I guess that's according to like the LoRa videos or something, or LoRa wired. But then that would require installing VPN server on the Android device. And let's look at the remarching code I'm talking about. Okay, so it does remarch sphere, or SDF sphere. I forget what SDF stands for. It's one of those mathematical shader thing toys. So this did work. I did have to move it back to the other layer. Let's see, screen record. Let me show it off real quick here. The FPS is a little laggy because it's been running for a second, and the phone like tries to save battery because like it actually drains the whole phone even though it's plugged in. So that square in the back, I mean that sphere in the background is the remarching sphere, and it looks like interesting because it has transparency. It looks like that evil star thing from Fifth Element. I can generate another view of it, or I could just move it up and change the radius, which would be. And then I have to reorganize my projects a little bit, but we're getting to the audio part here shortly. We're just kind of warming up on this. The audio has 2 different methods according to the Google page. Did I check it out yet? Get is not a recognized command. I knew it. Alright, so on this machine I don't have get installed command line. I should install it, but whatever. Rhythm game. So the OBOE library that they recommend has some compatibility stuff. So compatible with API 16 and onwards, but that's not what all it says. Or A audio API 27 plus. So this is recommended to be API 16 because API 19 I know, which I can't compile for one of my tablets. I mean, I can compile it, it just crashes for the, I think it's the tablet's fault, and because it's like Amazon's embedded Android system, so it's got some sort of system call issues, and maybe it's also the NDK not compatible with it. But like if you turn the ignore flags on, it'll get onto the machine and attempt to run. Anyway, so the OpenGL ES where did this come from? Okay, so it's always good to start here. Like I hate these Google developer pages. Like they just make me want to like tab out of them and just go to the next thing. So we went to the samples. We kind of read what the README said. I started to listen to this video. I haven't listened to the whole video yet. Okay, I haven't listened to this either. Okay. Let's just go through this in the background.
Many apps use audio to create amazing experiences, whether it's DJing, karaoke, or musical games. Audio is a powerful tool for expression.
Let's just do our own thing while that plays.
Today, I'm going to show you
I wonder if
how
it'll let
Obo,
me.
a new C++
I
audio library,
am
makes
fat.
it easy to build interesting, interactive audio experiences on Android. But first, what do we mean by interactive audio? Consider this keyboard. I press a key.
I
The keyboard
am
makes
fat.
a sound immediately. This makes the keyboard feel incredibly responsive because I get instant audible feedback. It's
Okay, so
playing an instrument
Windows
such a
doesn't
joyous
record
experience.
this anymore.
But imagine if after hitting a key,
I did compile Audacity on my
I
other
had
computer.
to wait to hear the sound. This delay or latency would make the keyboard difficult and frustrating.
So the first thing would be probably going out and getting this Audacity. It's an open source project, and it has FFmpeg library support, which is like awesome. But you have to import it, and it's a little hacky, but meaning like you got to be like
to provide a great user experience, and that's exactly what Obo does.
tech
library which makes it easy to
installer recommended.
audio latency on any given Android device.
We're gonna get this one.
It works with API
We could get the zip file one. I like the zip file ones usually.
99% of Android devices.
Actually, let's scrap that. Let's get the zip file one.
And above, falling back to OpenSLES
32-bit would be cool too.
This way, Obo
Because you could actually take source code out of Audacity and put it into your game in the 32-bit version if you're trying to really target stuff.
To get started with Obo, all you need to do is clone the repository from GitHub. This will copy the library to your local machine. Obo is designed to be built as a CMake sub-project. To build it, you need to update your project's CMake
Yeah, I don't want that.
configuration.
I don't want to do a CMake sub-project. That sounds like stupid.
First, tell your project where the Obo source code is. That's the path to which you cloned the repository.
So the thing I got back from the AI initially, the first one, the query I did to Meta, was actually the one that I feel like is the right solution, and I started writing it down in my notebook, and I kind of like stopped.
Now that's done, you can use Obo objects.
So we're just gonna like
by including the Obo header.
manually copy it
Obo namespace, so they
into
won't clash
Notepad.
with any other namespaces you might be using. Now you're ready to start using the Obo API. Check out the Getting Started guide, the code samples, and the code lab, all available on the GitHub site linked below. If you have any problems or questions, please post them in the issues section on our GitHub site, and we'll do our very best to help you out. You can learn more about Obo, including how to create low latency audio streams and a high priority audio callback in the next video in the series, Making Sounds with Obo.
Yeah,
That's all
this
for
is
now,
our
so
target
good luck.
knowledge.
Go make some noise.
I do want to document all this.
In the previous video, we saw just how important low latency is when creating interactive audio experiences. But how can you actually achieve this in your app? In this video, I'll show you how the Obo library helps you to create a low latency audio stream for playing sound. You can play sound through a number of different audio devices.
This will get faster here in a minute.
Wired headphones, USB audio devices, or over Bluetooth. An audio stream is used to
I know I could somehow copy paste this, maybe through my email, but
to create an audio stream, we use an audio stream builder. This allows us to set properties on the stream.
this will help us
It's
too.
best to leave most properties unspecified to allow Obo to pick the
This is inside your probably your main game place. You're gonna play the
there are a few properties which we should always set.
audio.
The performance mode should be set
So
to
native
low
activity.
latency.
This is the
The
hook
sharing mode should be set to exclusive.
of the
Once
library.
the stream properties have been
of
set,
the
you can
Android.
open the stream by passing a reference to an audio
We
stream
will
pointer.
cheat
Be sure
as
to
much
check
as
the stream
possible.
opened successfully, otherwise you won't have a valid stream object. If there was a problem, you can convert the error to a human readable stream using
This
convert
is
to
the
text.
F-read and
In
F-write
fact,
stuff.
Convert to text can be used to convert many
This
Obo
is the
objects to
F-read and
text.
write stuff that
Once
connects
the
with
stream has been
Java.
successfully opened, you can start it
This has
asynchronously.
JNI in
You
the
can now
name
send
of it.
data to the audio device. To put data into an audio stream, you can either write directly
and the
into
next
it,
one
or have the audio
is
stream
include
request
pound
data using a callback.
less than sign
Callbacks
SLES
use the lowest
slash
latency,
open
so it's best to use them for interactive audio.
SLES,
To create a callback object,
which sounds like
subclass
OpenGL
audio
but it's
stream
Open
callback
SLES
and
sound
override
library.
the on audio
Let me
render
copy
method.
paste that.
This
Include
method is called when the audio
OpenGL ES
stream requires
underscore Android. So this is the Android specific stuff. I wanted to go into these files and check out what's there to see how they actually wrote it. 'Cause it's actually Linux AA library rewrapped. Obviously, like they didn't like make the driver again. They just like recycled it.
Lastly,
Create
tells us how many frames of audio are
the
required. Each frame contains one or more samples.
OpenGL C engine, which basically just get the context.
Stereo stream has 2 samples per frame.
And then
One for the left channel and one for the right channel.
I really don't like
also tells us the maximum
recoding something that can be copy pasted, but
failure to supply data within this time is known as an underrun.
sometimes it's really
As an example,
nice because
if
you
our
really
audio stream
know
has a sample rate
your
of
stuff
48,000 samples per
about
second
the basic
and 192 frames
initial
are
setup.
requested, this gives us 4 milliseconds
So
to
this is
create
0,
data.
so we get
In the real world,
SLresult.
we want to keep well under this deadline
It's just
to
some
allow for
result
system
object.
overhead and late callbacks.
And then we do
To give you the best
SLCreateEngine
chance of meeting this audio deadline, on audio ready,
with the
high
engine
priority
object.
system thread, which means it won't be preempted
And we
by
didn't even
high
declare the
priority
engine
threads.
object. I noticed it
critical that you
didn't tell me how to
continue to work
declare
on
that,
what inside
which is
this
okay
menu.
because I'll just go look at some
More
GitHub
detailed
source
guidance
code
on
and
what you should and shouldn't do here
the-
can be found in the full guide to OBO on
figure it
GitHub.
out. It should be just
Inside
similar
on
to
audio
OpenGL.
ready, we write the requested number of
Comment,
audio
create
frames into the audio
output
data array.
mix
This
with
could be generated
one
using digital
output
synthesis or be supplied from
stream. So
pre-recorded
we may have
audio
to
data. Finally,
upgrade that to like
return
4
data
output
callback
streams or
result.
something, or
This
8.
can either be
I
continued,
believe 4 is like the minimal most games use, and 8 is the common.
stream should
But it
stop
could be
with
like
no more
crazier. I know
callbacks.
that some sounds,
Once you've finished creating your callback object,
some sound
link
systems
it to
are
your stream
very,
using
very,
builder
very
created
intense.
There's one
Like
final
they
step we
like
need to take to ensure our audio
literally
stream
will
has the
switch them
lowest
out for
possible
different
latency.
ones, and it'll
Setting
make the
its
game
buffer
sound
size.
so much better.
The
And
audio
audio
stream's buffer
guys
size
and
is
audio
the time it
people
takes for the
will
audio
really
frame to travel
hate
through
your
the stream
game if your
to the
audio's
device.
crap.
The larger the
Because
buffer,
you
the
could
longer it
waste
takes, and the higher the latency. An optimally
like
sized
almost the
buffer
same amount of
is a
time
key
on
trade-off
audio
between latency and underrun protection.
development of the engine
Buffer size must be a
for the
multiple of
code
the stream's burst
as
size,
the
the number
graphics,
of
I
frames
guess,
the audio device
because the
consumes
graphics is
in a
so well
single
defined,
read.
while the audio nobody,
A good rule of thumb is to use twice this burst size.
no one
This means
pays
that
attention
if
to at the beginning.
occasionally we miss our audio callback deadline,
But in our
will
purposes,
not
we just
hear
want to
an
play
audio
sound.
glitch
Like this is
as long
just
as
raw.
the
Just
next callback runs on
get a
time.
WAV file or a
Use getFrames
OBJ
to burst
or
to get burst
OGG
size,
file.
set
I think
buffer
is
size in
OGG
frames,
is what
set
we're gonna have to
buffer
encode.
size.
And we may
Now
have
that
to
all the
grab
stream properties are
MPEG
set
after we
and
install
start
this.
the
Okay,
stream,
so we got
callbacks will start immediately.
Audacity. We
And once you've
downloaded
finished with
our
the stream, remember to close it. After you close the stream,
Audacity
you cannot
and we
exit.
extracted it.
You should now have
And I
everything
want
you
people
need
to
play
take
audio
a look at
using
Audacity
low
for a
latency
second
audio
here.
stream. For a working
Basically the
example,
same thing I
check
did
out
with
the
my.
Hello
Okay,
Obo
so we're
sample on
coding
GitHub.
result
Shows you
equals
how to
engine
create a
object.
simple synthesizer app.
I really
It
don't like
also
this name,
demonstrates
engine
how to
object,
handle audio
because
device
it's
changes,
actually the
such
audio
as when the user connects their
engine
headphones.
object.
The link can be found
Create
below.
output.
In the next episode,
We'll rename
I'll show you
things
how
maybe
to
later,
record
but
sound through a microphone
today we're just
using
trying to
low-latency input streams.
pump
That's all
and
for now, so good luck,
inject.
and go make some noise.
Yes. Just Google video is more motivational than anything. I really don't like that. It's just like, oh, I feel motivated, but I have no clue what I'm doing. And it's
In
just
the
like,
previous videos, we've seen how the Obo library makes it easy to play low latency audio, but what if you need to record audio? In this video, I'll
oh
show you
yeah,
how to
that would
set
be
up
actually really
low
cool.
latency streams for recording. Recording audio is done in much the same way as playing audio. The main difference is that our audio stream moves data
Okay.
from an audio device, for
So
example,
we
a
created
built-in
this,
microphone, rather than sending data to it.
created an output mixer. Create output mix, I would say, is one mix channel, but we could have made more mix channels, but for now we just want one mix channel, just so we could hear the sound and it'll override the other sound playing, I guess, or won't let us. Step 3 is to load the WAV file, or load the default format that I guess most stuff uses is now OGG, but I could be wrong. I'm still like really new at this, so this is the challenge here.
It's possible to obtain the lowest latency using both approaches. I'll demonstrate
So
how to
Asset
do
Manager
direct
is our
stream,
fread
since the callback
way
method
of
was covered in the previous video.
accessing files, and we
The
have to
method
put it
we
into
use is
asset folder.
unsurprisingly called read. It takes 3 parameters:
Most of us Android
is an array
developer
into which
people
the
kind of
audio
know
data
that,
will
but
be read.
a lot of people don't
Number
know that.
frames
And
is the number of audio
Unity
frames
or
to read.
Unreal or
Timeout
Lumberyard,
nanoseconds
then
is
they
the
will be
maximum
like,
number of
or
nanoseconds which the method will block for.
go to,
If you specify 0 here, the method will
like they have their
return
own asset
immediately
managers. This is like
only
basically
the
what we're
data
doing.
that is currently available in
You open the
stream
asset
buffer.
manager, you tell them,
This is
oh,
useful
well,
if you don't
get
want to
this
stop
file.
the current thread. So, let's say we wanted to read
The
2
context of the
milliseconds
asset
audio
manager is
data
passed
from a
in,
16-bit mono audio stream. We can do
and
this
then
using
the
a
path.
built-in read. Start by creating
We'll
an
just
array
put,
of stored frames of audio. The
play
amount of data we need to store will depend on the stream's
wave
sample rate. The timeout should be longer than the amount of audio we want to read.
asset mode
In this case,
unknown.
we'll use 3 milliseconds
That
and
sounds
convert it to nanoseconds. Incidentally,
promising.
OPENSLES provides a number of useful constants for working with different time units.
When your mode is
Before we can
unknown,
read from our
it's
stream,
really
we
promising.
need to clear out any stale data
Wait,
which might already be in the stream's
I
buffer.
did this wrong. Okay,
To do
I
this,
was supposed to
we
write
just
the
perform
command get
non-blocking
the
reads of the whole
asset
buffer until it's
manager
empty. Now, when we read from the stream, we know we're reading the most current audio
Then
data.
get the
After
file
reading completed,
size.
we need to check the result. If it was okay,
Make sure we
then
know
result value
how
will
much
contain
the
number
offset
of
is.
frames
That's why
which
we're
were
getting the
copied
file
into our
size,
buffer. To
which is
read
probably
more
just an
data,
int, but
round
it's
clock
typed
while
as off t, which
This
is the
approach
same thing as
allows
like
us to
size t
process small
probably.
buffers of up-to-date audio data
I say
for
probably
processing and
because
moving
I could be
elsewhere.
wrong. Maybe it's a long,
After we're
but
done,
then
just close the
32-bit,
stream, and after
you won't
the stream's
support
been
it, and you have to
closed, it
backport
can no
that,
longer be
and
accessed.
all kinds of fun stuff. There's
This
always
is a very
the
simple
size t
example of
problem.
how to record audio.
But you gotta just like
For more
know how to
complex
solve these
examples,
basic
including
problems
how
all
to
the time
synchronous recording and
when you
playback,
port
check
stuff.
out the live effects sample on
Porting
GitHub.
is just a job in
You
itself.
can also
There's like a
check out the
YouTube
other
video on
videos in this series.
how this guy was
The
just
first
porting
video,
these games off of
Introduction to OPENSLES, shows why low
NAS,
latency
then
audio
to
is important.
PC, then from PC
And the
to
second video
Android,
shows
and
you how to create
just made
low
money that
latency
way,
audio
just
streams
because
for playing sound.
many people don't know how
That's
to
all for
port.
now. If you have any questions,
I was like,
issues,
oh
or
man, this is like
feature
my
requests,
stereo. If I wanted to
please
just,
post them in
if
the
I thought
issues
I could just
section
do
of
this,
the
I
OPENSLES
can't.
GitHub site. We'd really love to hear from you. Good luck, and go make some noise.
Okay, I missed half of what the video said, but who cares? Just watch it over and over again later. Okay. Close the asset. Do garbage destruction.
Hi everyone,
Clean
thank
up.
you for joining us at Best Practices for Themes and Styles. I'm Alan,
Hi, my name is Nick Butcher.
and we're going to be talking about some ways to think about themes and styles at a high level and how...
Yeah, we don't want to watch that at all. That's gonna just, that's diluted information.
Latency approached launching on Android.
Alright, so this comes from 2017.
Good morning, everyone. I'm Kelly, and I work with music and audio app developers to help them launch and build successful businesses
Okay,
on
here's our
Google
file.
Play. We're really excited to be here today to share with you both
I
technical
hope this will
and
work.
business best practices for developers that require
How do I-
high-quality audio.
Asset manager.
So our session is divided into 3 parts. I'm first going to share with you tips from leading audio developers
I didn't
who
do
have
this right, did
successfully
I?
built
Nope.
businesses on Android. Then Dawn is going to join me on
It's
stage
actually supposed to be
to
like
share
this. Asset
common
manager
technical
is equal
hurdles that
to.
audio developers face
But
and ways to overcome them.
If the
Then
AI
Phil
wrote this
will be
wrong,
announcing our latest A-audio
this is
framework
just
that
a
we think
pseudocode
will help
of what I really
developers
need to
reach their
do.
performance needs. Then to wrap things up, we'll have Roland, Rolly's CEO, join us on stage
Yeah,
for a really cool live music demo.
but I
so
have
stick
this
around.
already for the texture codes.
So
This
I
is
have
essentially
Los
like
Angeles,
how you
California, in a very musical family.
import your textures. The
And I
same way you're
remember
going
the
to
first time
import
I
your
stepped foot
sound
into
and
a
other
music
files. It's
studio.
going to be
It was really
similar-ish.
exciting,
Not
but I was
exactly the
also a
same
bit
because.
overwhelmed by the amount of professional tools and expensive equipment, and not to mention that
Okay,
running the
so
music
first we get the
studio
asset
itself
manager, then
wasn't
we get
exactly
the
affordable.
AS
As a
set,
teenager,
which is the
these
asset
DJ turntables
type
were my favorite piece of equipment
pointer to
because
it.
I thought it was pretty cool being able to mix my favorite beats for my friends. But as cool as these turntables are, having access to expensive equipment or an expensive studio isn't
Yeah, because
really
you could
feasible
just
for most
make
people.
your sound
So luckily, for
studio
the
right
millions
inside
of
your
people around
phone
the
using
world who
Android.
want to produce music creation has changed drastically. Now, with the accessibility of mobile, you can simply download an app and have pro-like quality music instrument and a music studio directly
Yeah, you can
in
just
your
download a
pocket,
violin
making
quality
these DJ turntables
thing.
accessible
Not need
to
that
everyone on their
violin
phone.
guy that died.
And
No
that's
one knows how
why
to make
we've
those
seen
violins
tremendous
anymore.
popularity
They're so
in apps
expensive.
like EDJ DJing.
He used like
with
some
over
special
45
wood.
million installs.
There's just
But
like
of
a
course,
legend
it's
about
not
it.
just DJ apps that have grown in popularity.
So the music
It's
sound
apps that
beats
allow
it's
you to sing
very
karaoke, such as SLES with over 52
close
million
copyrighted
monthly
type
active users,
industry, but
and apps like Oscillator that recently released
Alright.
on Android. And while high-quality audio is important to music creation apps, it's also important to a whole
to make their
host
sound
of
real
other
quick
apps,
and just
such as
inject it.
VR or
How does
voice
you
to
project
live
editor
apps
are
or
currently
games.
on a social
And the
velocity?
market for
Would you like
high-quality
this?
audio
Yes,
apps is
fine,
only
yes.
expanding. So
Then
that's
what we
why I'd
do
like
is
to
we
now dive
pin
deeper into the
Audacity to our
first part of
desktop.
our agenda,
Where did it
which is
go?
sharing with you
We pin
3
this
best
to our
practices from leading
taskbar,
audio
desktop,
developers
whatever.
who have successfully
Update checking,
launched
blah
and
blah
built
blah.
their
No, I
businesses
don't want
on
any of
NULL.
that. Available on MuseHub.
These best practices
What
are
is this?
launch smart, think global, and everyone's favorite, make more money.
Not just over the
So first, launch
Okay,
smart.
he tells us how to do crazy shit. Watch release video. What's
So
new
we
in
know that
Audacity?
device fragmentation on Android can be a major challenge for developers that require high-performance audio.
Adding the real-time
In order
compressor
to deliver
applies
the
to your
best
overall
user
mix.
experience,
Yeah, that's cool. You could
it's
do
important to
the
understand what
the stuff
device,
that people make you
work
pay
well
for.
your performance needs. By
Hello,
performance
I'd
here,
like
I'm
to
specifically
eat
talking about a
burgers
device's
because
CPU
if my
and
farts
latency.
are not
The
good
lower
enough.
the latency, the better the user experience. So let's take a
Hello,
look
I'd
now
like
at how
to
Joy
eat
Tunes, an app
burgers
that
because
requires
if my
low
farts are
latency,
not good enough.
approached launching on Android in
Okay,
order to
so I'm gonna
maximize
roll
their reach,
sound.
but still achieve a good user experience.
Export audio.
So Joy Tunes is the creator of Simply Piano. a
They've added these new
subscription-based
features.
music
I
app
have
that
the
helps
other
users
Audacity
learn how to
compiled on my
play
computer,
piano.
the old school.
In fact,
Okay, so
my
we have
daughter
Wave,
here
OGG.
has learned
Let's
how to
try
play
to shoot
piano
for
almost
OGG.
exclusively on this app.
We'll
So
name
we've
this
had a
play
piano in my
that
household her
OGG.
entire life, and it wasn't until I introduced
Sample
her to
rate
this
should be
app
this.
did
This
she
is
think
our
that
default
playing
sample.
piano
If
was
your
all of a
sample
sudden
rates are
fun.
wrong, which somebody gave me a
So
bunch
what
of
she does
sounds
is
one
she
time
simply follows
for my
along,
other game
to the
on
guided
Source
lessons
1,
on
and
our
the sample
piano,
rates are
and
all
the app
different.
immediately
It
recognizes
screwed
what
everything
she's
up. It
playing
just wasted all
and
my
then
time, and I
provides
was
feedback
just
to her to help her improve.
dead from
So
trying to
the
fix
key
it.
here is that
And
when
he
my
just
daughter
killed me.
presses
He
down on the
basically
piano
virused me
keys,
by...
she expects that Simply Piano will
whatever.
immediately and accurately hear what she's
I should
playing
export to a
and
different
provide
folder.
feedback. But in order
That's
to have this experience,
you have to every time you have to
Simply
click on
Piano
that. That's
requires low
terrible.
latency of playback and recording of
So
musical
I wonder
tracks.
if I could play
So to
OGG
figure
now
out
on
what
C++
devices meet
Windows.
their, low latency and computational performance needs, they first launched a beta version of their app in our Early Access collection. So Early Access is a collection on Google Play for new selected apps that are still in beta. Inclusion in this collection enabled JoyTunes to build a beta audience and to be able to collect private user feedback. This enabled them to identify both problematic devices where users were having a poor quality audio experience, but also problematic regions
when I was
that they
talking
were
about
then
the
able
whole
to exclude from their production version.
OCD thing.
They also developed a way
So
to
this
have
is
their
the
app
other way
work
that they're
on
doing it.
lower-end devices.
Yeah, the
By
buffer
making
data is.
automatic adjustments
So
of
in
certain
OpenGL,
features, such as
which is the other,
changing
yeah,
and
load and
optimizing
decode
graphics
OGG.
so that a user on a particular device would still have a good experience. So with all of these learnings, JoyTunes was
So
able
I would
to then
do
launch to a
OpenGL on
public
PC
audience
since it's just
with a
so well
very
founded
high user
for
rating
Linux.
of over 4.3, and to also launch to
And
a larger
for-
number of devices than they had originally thought possible. So second,
Yeah, so it's not OpenAL,
you
but
wanna
it's
think global when you think
OpenSLES
about launching your app
1.0
and
for
growing your
Android
user base.
because
And
Android has
tremendous
to be
strength here, and we continue to
OpenSL.
see enormous growth of music creativity apps in both developed
This
and
is a
emerging
good
countries.
answer question
When
on
expanding to
Stack
developing
Overflow.
regions, though,
Very,
you want to optimize your app
very on
for
topic.
specific needs for users that are in that market. For instance, you may find that there's a higher number of users that are on low-end devices, and you may find that more users have
Yeah,
lower
like I'm trying to like
bandwidth.
recycle
But
low-end
that
devices
means
because like if you can make it
don't
work on
limit
low-end
the app to
devices,
the
you've
cheaper
just
devices. There's a
really
number
got
of
all the user
things
base that you need. They'll just
optimize
download your
your
app
for both
because
high
there'll
and
be no
low
other app
devices.
but yours.
So let's take a look now at
And
another
most
leading
devices
audio
are better than a
developer
Raspberry
that
Pi.
has been distributed
4,
globally, but has seen
not just
enormous
0,
success
like
in
4.
emerging markets.
They're all quad cores.
So SLES is a leading developer of
Smule.
mobile music apps,
Hello,
including
it's so
Simplified,
funny.
that allows users
Their name
to
is
sing
Smule.
along to their favorite songs in a karaoke style
Sounds like
fashion.
Mule and
So
Smeagol
for
combined.
instance, if I wanted to sing, or if any of you wanted to sing Disney Frozen's Let It Go,
Alright, so
the
let's
app
copy
would
paste
match
in
up
our
what I'm
sound
singing
file.
in real time with the song, and then I'd be able to overlay audio graphics to make my humble voice sound like a pop star. If Disney
Audio
sing-alongs aren't
graphics,
popular
that
in your
sounds
household,
very
they have a ton of other genres too.
Appealing.
So Smule has
attractive.
seen phenomenal growth, but
Okay, why is
last
this
year,
called
the app saw over 10
That's not the right name.
Install growth in
Okay,
the
so
Southeast Asia region. With over
go copy
40%
your
of their user base
OGG
now
file.
comes from this region,
Double click on it,
Indonesia
see what
being
media
one of their
player will.
fastest growing countries.
It'll just at least read
But
it.
not only have they seen enormous active user install
Hello,
growth,
I'd like
they've
to
also
eat
been monetizing
burgers
well there.
because my farts
So,
are
with
not good
over
enough.
7x increase in revenue over the same year in the Southeast Asia region. So in addition to some of the technical optimizations that they've done, another
Alright, so
reason for
it's
this
being
viral
dumped into
uptick
this
can be
project.
attributed
We're going to
to
dump it
Seal
into the other
offering
project and
locally relevant
re-replicate what we tried
content.
here.
For instance,
Because I believe
user
I
in
will destroy my
Indonesia,
project here
pictured
soon.
on the left with the headphones,
I just have a
can
feeling
sing along
it
to
usually
one of the
happens in the
world's
first
top hits,
attempt.
or she can
Do
choose
something
to
like
sing in a duet-style
surgical as this.
karaoke with one of
When you
her
surgically
favorite
just copy
regional
pasting
artists,
code off the
such as
internet,
Sita, pictured on the
prepare to
right,
destroy
who's a
your
very
project
popular
twice. So
Indonesian
make two
singer.
backups. One is the
So
destroy
after you
backup and one is the
understand
Twitch
your
backup
reach,
of
you
what if I
want to
fix this
identify
but
areas
not
of
fix that.
growth, and then create
And
a
then make another
localized
two
experience for that
when you
market.
break those
I
two.
also encourage
So you gotta
to
make
check
sure you're
out
always
our
on top
Building
of.
for Billions guidelines online
Alright,
if you're
so
interested in more tips on building for emerging markets.
this is
Lastly,
our
you
little.
want to ensure that you're testing your monetization strategy to achieve the best business
How do I
results.
update my?
So many music creation apps have historically required that users pay a premium price in order to access their app. But because of the variety of payments that are available on
How do
mobile,
I update my
user consumption
YouTube
habits have
stream
changed.
thing?
And in fact, on Play,
Description.
our
Oh, I can do it
fastest
later.
growing business model comes from subscriptions.
You have to watch
where
this
we've
in order
seen
to get
both
this code
subscribers
anyway.
and revenue double over the
So
last year.
we're not gonna need these
So while the
three
last two apps
probably.
that I mentioned, Simply Piano and Smule,
Image
allow
decoder.
users to download
So this
the app
actually
for
I have
free
it
and
also
test
in
it
some of
out
my
and then
app
sign up for a subscription.
to support.
The developers of Ultimate
I know that
Guitar
this
Tabs
is not the
have
right file to
tested
do it
an
in,
interesting
Renderer,
hybrid model. So Ultimate
but
Guitar Tabs allows you to learn how to play guitar through in-app lessons, or you can just jam to your
I don't know,
favorite
let's
song. So Ultimate Guitar started off as a premium
let's
app,
use
but
our
rather
other
than
project
charging a
because it
high
has
price
jump.
point, they experimented with a lower price point for a paid app, allowing users to
make sure
download
this
the app
works.
for $2.99, as you can see on the left. This essentially lowered the barrier to entry. Then they upsold their users once they were in the app, allowing them to download the full version for $9.99, as you can see on the right. So this hybrid approach of using paid and in-app purchases turned out
alright,
to be an
jump
effective
works.
monetization model for Ultimate Guitar Tabs. They not only
it
increase their revenue
compiles.
overall, but in-app
Got a
purchases now
spaghetti
account
code of
for
shaders.
65% of their revenue, which is a pretty striking stat given their
Yeah, so you could pass some of the
premium app.
audio stream somehow
So
into
while
the
hybrid approach works
shader.
for them,
Should be
I
nice
encourage you to
because
test
that's
out
how you do
different
your audio
monetization
graph.
models beyond premium and see where
Some
you
of this
have
we
the
won't
best
need. I
conversion
believe we
results.
don't need this.
So these are just a few examples
This.
of audio developers that are seeing
Just keep
tremendous
this,
success
and
on
if we get
Android.
errors, we'll just figure that out.
There's a tremendous appetite for music creativity apps, and so we think if you follow the business tips that I just gave, and also some of the technical tips that Dawn and Phil will be sharing, that there's a
How
big
does
opportunity for
this
developers
work?
in this space.
Okay, so
I would
in
now like to
main,
introduce Dawn to the stage to discuss common technical hurdles and how developers can overcome them. Thank you.
Hello, hello.
so renderer.
Thank you, Kelly.
We'll just declare this in renderer,
Hi,
and
I'm
then
Don.
I
I'm
see
a
renderer is
program
basically our
developer, and I
game.c++.
lead our developer efforts for the Android high-performance audio framework.
And
What that
later we
means
could.
is I help you guys create amazing audio experiences on Android. What it actually means is I spend virtually all my time listening to sine waves. Outside of Google, I do a bit of DJing, and in my head,
Yeah, exactly.
I
The
like
sine
to
wave
DJ
sounds like a
in
Half-Life
places
2
like
death
this.
sound. Well, at a
The
certain
reality
frequency.
is actually probably closer to this. More people definitely turned up later, I promise. Okay, so today I'm going to give
Okay,
you
so we
two best
initialize renderer
practices
right
which you
here.
can use in
Once
your
you're
apps
done
to create
initializing
amazing
renderer
audio experiences. These are
and allocating some model
obtain low
stuff, let's
latency audio
do
files
our.
and meet your audio deadlines so you don't give your users headaches by putting audio glitches into their ears.
And we'll
So,
declare just non-prototype
so starting with obtain low latency paths. I'm going to talk about
stuff,
two
and then we
signal
could
paths
later
through the
port,
through the Android system.
copy paste it to a different
Number
place,
one, recording, and number two,
different file. But
playback.
alright,
Now,
so
one of the
create
first
the
questions that I
OpenGL
often get
SL.
from developers is, what is the latency of this path?
So we have one function.
This is the thinking behind the audio.pro hardware feature flag. And if a device reports support for this flag, it means that this particular path
Load the
is
sound.
less than 20
I think I didn't write
milliseconds,
everything on this
over
file.
the headset. you can use this flag in your app to either enable certain features, such as live monitoring, or you can only distribute to these devices, these pro audio devices. And there's now tens of
In our
devices in
case,
market which are supporting this
we will
particular
just
standard.
load
So
it
it's not just
straight off the
Pixel
bat.
and Nexus devices. We're seeing good uptake from OEMs as
Then
well.
we'll have to
So,
make it global. Change
audio
wave to
recording.
OGG.
this is the path
Import the
through
sound
the
again.
Android audio framework when you're recording. You have an analog signal into a microphone, goes through an analog to digital converter, through some effects to kind of clean up the signal. This can be things like noise cancellation and echo cancellation.
Alright, so
And then the digital data is delivered to your app. Now, effects.
oh yeah,
and,
so
latency.
we forgot
So
about
if-
step
If
4.
we're talking about low latency apps, what
Step
we want
4.
is the lowest possible latency. And there is a route through the system which allows us to avoid adding this
Create a
latency.
player.
And this is obtained using the voice recognition.
Not the
preset.
player that plays the game,
The
the
other thing
player
we need
that
to
plays
remember
the
here is
sound.
to use
This
PCM
is
16 format, and this
ambiguous or
essentially allows
confusing,
the
and
audio framework to
forgot
not
the other
do
word
any
for it.
format shifting, which potentially could add latency. So
There's always
that's all
things
I'm gonna
called
say
the
about
same
audio
thing in
recording.
programming, and they get really annoying.
Audio
So
playback
when you're in
is
the
a
middle of the
little
night
bit more
and it's like no
complicated.
more brain power, you die.
Every phone that produces audio in the world has a digital to analog converter in it. This takes ones and noughts and converts it into a voltage.
So you have to do
which
something
is
like
used to drive,
SLresult,
headphones or a
result
speaker.
type Android
Now,
data
I like to think of this as
locator
kind of a
underscore
character,
Android simple buffer
which is
Q.
chomping down on this audio data and producing this
What a
signal. In
name.
fact, I even have a name for him.
All these nice names.
DACman.
It's like you can't memorize this. It's
Now,
too long.
DACman
Especially when you do it the first
has
time. It's like you're never gonna remember that.
very
Well, later,
specific
once you've
requirements
just
for his
pulled your
food.
hair out multiple
He
times,
wants it served to him at a
and
certain
it cuts
rate.
off, and it cuts off.
And he also
So
wants it
like
served to him in
all I can see
bite-sized
is that it
chunks
says
of a very
data
specific size.
lock.
Now, for this analogy to work,
But I could guess
DACman
it's
also includes
data
a
location,
DMA
so what we have to
controller and all
do-
the other hardware required to consume audio. So just bear with it. So this is how DACman fits in to the Android audio architecture. So your app is at the top here, and it's your job to get your audio data to the output as quickly as possible. The default path through the system is to go through a resampler, through some effects, again, to improve the acoustic quality of the signal, and then through a mixer and out to DACman. Now,
that
as with the
sounds
recording path,
a headache.
the resampler and effects will add latency, and we can obtain a lower latency path called the fast mixer path if our app conforms to certain requirements. So, number one, we need to obtain the correct sample rate. So remember I said DACman wants his food at a specific rate. We can use the Audio Manager API to find out exactly what that rate is. And that will enable us to create an audio stream on this fast path. The other thing we need to remember is
And
not
this is
to
what
add any
we
effects.
Yeah, so we did include for native
Once we've
audio.
created this audio stream to DACman,
Audio
we need to start
play.h,
supplying
whatever
audio
that
data.
is.
And we need to do it in this
We're
specific
trying
chunk size.
to
And again, we can use the
find
Audio Manager API to obtain this optimal size. So after this first chunk of audio data is consumed by DACman, he sends us a callback. He's
it's a
basically
lot more
saying,
detailed than
I've run out of food, feed
I
me
wanted
more.
it to be.
And we get this
But
callback
this looks
on
like
a high
it's going to
priority
get it to
thread.
work
This allows
eventually.
you to do your audio processing work without being preempted by other parts of the system. Now, this is a fairly critical part of any audio app, so let's take a closer look at what happens inside this callback. So every callback has a
BRB.
deadline. Remember that you have to send these chunks of audio data at very specific intervals. So the amount of time you spend in this callback is going to vary based on the computations that you're performing, like the complexity of the audio data, but also CPU frequency and the device that you're running on. If you miss this deadline, DACman is going to be very unhappy, and he's going to output silence in protest. So it's very important that we don't miss these deadlines. So for the next part, I wanted to talk about some common reasons why you might miss these audio deadlines. So starting with blocking. So inside your callback, there are various reasons you might block. And here I have a code sample which does a whole lot of bad things you shouldn't do in your callback. So number one,
Alright, so now I need to go drink more coffee because I just got rid of the coffee off of my body. Oh. He's talking about the thing I was trying to do.
Use memory inside the callback, which invariably you do. You should allocate the memory up front when you instantiate your audio stream, and then just use it inside here rather than trying to allocate new memory. Wait on other threads. Bear in mind, this is a high priority callback. So if you're waiting on a lower priority thread, you have priority inversion. Don't do file I/O. If you need to read from a file, use another thread and then use a non-blocking queue or a circular buffer to transfer data into the callback. And don't sleep. There should never be any need to sleep inside here. So we've dealt
impossible.
with blocking. The next reason why you might miss your deadlines is core migrations. Now, when you create an audio app on Android, the CPU scheduler will assign your audio thread to a particular core. And here I have a systrace, which is showing the audio thread running on CPU 1. And we have 4 callbacks marked in those green rectangles there are the callbacks. The other row of interest is fready1 here, which shows us the state of our audio buffer. And we have 4 callbacks. And
we're going to have to do all this. It's too complicated. No, we'll have to.
Now, this core migration can incur a slight time penalty in the order of a few milliseconds. And this can cause our callback to start late and therefore run over. And sure enough, we have an audio glitch occurring there. So, the solution to this is to set thread affinity, which means that we can bind our audio thread either to the current core which we're assigned. That's like
this code right here. What's it? If it's thread infinity, gets the CPU it's running on, gets its thread ID, sets CPU 0, current CPUs, and what is it doing? Oh, it's setting the CPU it wants to send the settings to the current CPU. Not the current CPU of the main thread, but the current CPU that it's going to schedule a set affinity to. Then it sets the thread ID to that CPU to have a more priority, or a certain type of priority, so it doesn't like do that. Audio animation callbacks. Yeah, so the AI couldn't explain this to me because this is monstrous. I mean, it's just a beast code. Play clip, the buffer. Okay, this is what we need. We just need this play clip thing. Audio play, set playing true. Result equals player buffer queue. Wow. We're gonna have to globally allocate our engine object. Our engine object should be what file we got. How long is this? Well, we only need like 500 lines of code, which is not that bad. Maybe a DH file too. Cribbled from samples native audio. So let's look at these 2 files and then we'll move on to our next scheme of things, which will be to let's save a WAV file. Let's look at the native project for a second here. NDK samples. It's not audio, oh, it's native audio that we want. Native audio, and there's a codecs. Source. Assets. Background at MP3, so MP3 could be in one. What about in native codecs? MP4. So native codecs is video. Native audio is MP3 audio. Java file is a simple click and play. Oh, this is always good. H file with a bunch of hex in it. Why would you do this? Okay. Yeah, so they use pthread, SLES, OpenSLES, asset manager types, hello clip. Alright, so that's how they include a hex file. Status const char equals include pound. I've never seen that used like that, but that's cool. Okay, buffer queue player. So we need all these objects potentially. Okay, pthread music initializer. Alright, let's run native audio and record the screen. We're gonna need to know what this does first. Alright, so this is doing some of the stuff we're doing. Create engine. SLCreateEngine, realize, get interface, we don't have that. It has interface IDs. Then we have another realize. Then we have a generate interface and environmental reverb properties. Okay, nice stuff. Audio formatting for the buffer queue format, number of buffers 2, channels 1, sample per second, speaker front center. Oh, it would be cool to play 2 sounds in one speaker and then the other. That'll be a nice, it's still building. We're recording the video. Let's see, we'll stop recording this and just override. Should build here in a minute. Interface, audio sync. Alright, so it's built. It's installing. Okay, successfully installed on the device. Okay, cool. Hello. Alright, let's pull the video. Get the idea here. This is what the native audio app is. It'll load here in about a second. So I can't play both sounds at once. It doesn't allow for that.
Did they end up showing up or no?
Who?
The probation?
No. Alright, so I don't know if the video plays it back, but I recorded the sound and it plays finger snapping sounds. And you see that it asks for permissions to get the audio, and you can see the little microphone on top. Alright, so now look at the JNI called set looping audio, set mute, solo if. So all these audio player things, and it always like bogs down to all this like unnecessary features that they enable, and then you're like even more lost, like reverb. Then next buffer. This is where you press play, I guess. As you press play, it puts it in queue and sends it off to the thread. And we know it's using the thread because it's using the mutex engine, audio engine lock. Now there's a mutex, oh yeah, especially if there's a P thread on, it's going to mutex unlock. That ensures you don't like crash your program by writing to the other data the thread is writing to. Kind of slowly scrolling through this, but so it looks like there's more stuff than the AI gave me in the morning. Start recording. Recording would be cool too. Shut down. Alright, so we're at the end. I don't get that's where they loaded the background sound. That's where like the fun begins in our. Alright. So it begins in this create asset audio player, and it's being done in Java. Ah, disgusting. So they're doing stuff in Java and in C++, but most of it is in C++, so I'm kind of overreacting here. We'll find out here in a second. It's not so like pre-cache. This is the pre-cache. Once it's cached. All right. So then once you pass in this. All right. So the asset manager can open UTF files. Okay, so we need to add this first. I can just see the differences here. Somehow. Asset manager open from Java. The J string. Ugh. For Java string to UTF-8, so we might not need this. Let's just ignore that. I think that's just an extra Java bloat. We won't need that. If null equals asset. I've never seen it like written like that. Usually it's null is at the end, but whatever. Start length. Open file descriptor, we're going to need this. Before we close the asset, we have to read out oh, it's the same thing as this. The length is probably the same thing as file size. But we'll see if both work. For some reason it's a different function. Get the format. Alright. Configure the audio source. Configure audio sync. Create audio player. Realize audio player, get the play interface, get the seek interface, get the mute solo interface. Get the volume. Enable whole file looping. JNI return true. So all we need to do here is get the rest of the initialization after that, which is, what was this, step 3? We have to make a new file for a tutorial. Step 3, load the audio file. Create the player. Yeah, that's what step 4 is. Essentially, it's going to be like, we'll save this too. It's not the final thing, but whatever. So and I would use the GitHub for reference, but I actually wanted to go to GitHub and find more stuff. We don't declare any of these objects that they declared. And I believe they declared them globally. lost again. Oh no. Yeah, they're like static objects. It's a bunch of... We're gonna have to rewrite the whole file. We could also use these hello and Android clips too, but alright, let's just make this easy as possible. We won't touch the recorder for yet, but basically from native audio, copy the first part of the headers. Okay. See what we get if we try to compile this. That'll just point us to kind of what we have to fix next. Okay. So now I want to exclude these. Because really, according to the sample, the embedded soundtrack is a different type. There's play this. These four are in that index, and this is some other thingamajigger. So see what this calls in the Java file. When he presses embedded soundtrack, There's also playing off of URL, so you could actually put your files onto like GitHub. So your your game is like smaller, and then just like stream them or download them, but it's almost the same thing because they're so small. Create engine. Alright. Public static native void. Public static native void. Let's see where that function is. Those were the declarations. Ah man, this is like where they create the button code or something. Let's see. Yeah. So this is the constructor of the interface. It's embedded soundtrack. It's the one we want. Set playing audio player is playing asset. This is what we want. We want to set playing audio player set asset equals true. Create asset audio player. Go to declaration usages. Set play state. Oh good, we're in the SLH file. Didn't go to the right place really. Native audio JNIS. So all that really has to happen is we're already calling the raw method. So what we're going to name this is play sound. It's going to be called how's this being passed in is playing. I believe it has to be true, right? Alright, how do we initialize the engine? I believe it's all this stuff. Create asset audio player, yeah, it's this stuff. I have to redo this. Okay, here he loads the asset. Let's just copy paste their code and then do it like this. First truncate this. Copy everything from line 1 to not line end. Now I'm going to need the Java UTF thing. We do need to get the asset manager though. Oh no, we closed our file. So we did have one thing that was going for us. Get the asset manager. Anything else we don't need to do. Manic anger. Asset manager from Java. Oh no. Let's go to texture asset. Let's see how they do it. Load asset manager. So create asset from asset. Find load asset in our project. Asset manager. Texture asset. It's not the right place, of course. App underscore activity. File and render, right? Yes, this is how we get our asset manager like this. So asset manager is just equal to app underscore activity pointer asset manager. And why don't we have access to this? That's stupid. You should have access to this. I see why, because we're not inside the class. But the question is, how does he get the asset manager in the first place? Yeah, he gets it right here. He passes Android app into app pointer. Struct Android app. Yeah, so we're gonna have to put that into sound thing later. Great. More complications. Okay. Now we got the asset manager. And it's pissed. What's E and V? Whatever. We don't need that. We have to name it MGR. Please speak with leadership. Or something. Then we have to get our asset the way we did initially. So it's like I'm merging 3 code bases here somehow. Don't ask why. And I knew for some reason it would have to be this way. Don't ask how. I feel like I've done this before in a different dimension. Alright, so return. We don't need this. We do need a return. We need to do return. A out. Something went wrong. We'll put error inline so it looks humanly readable. Is this an error? It shouldn't be, but whatever. It always hates. Alright. Load sound we're not going to need. For now, we're just going to need play sound. Visual Studio does commenting out differently. It spawns the next end tag for you, which is so annoying. Asset Manager, did you mean AA Asset Manager? You're an AA. Okay. Because this is going to need a whole like thing to load a bunch of sounds. And you could take one sound file and cut it up with this buffer thing, I guess, and do what textures do. That'll be an interesting project. Like I had it somewhere already. Let's see, let's recompile this. I thought I pasted it in somewhere. The use of undeclared inline. Do you mean std out? No, I don't. Cheers. Okay, that's fixed. Ugh, okay. See if this will compile and just run on device. Then we'll do next step. Oh no. What do you mean tool chain clang is pissed? Broke something. Oh, okay. Let's already put this in. We're not going to run it. We're not going to have capability to run it, but we'll have it embedded into the code. And this is not the right way of doing this because we don't have multiple channels like we should. Like watch a whole video and like finish watching the rest of the other video to figure that out. Huh. What's wrong here? Oh, undefined symbol SLID seek. Why not? It should be a part of the file. Crack. I know it's inside that H file. It should be in here. Okay. Let's find it. Go to declaration or usages. Yeah, it's in there. It's exactly where I thought it would be. Well, kind of. Okay, why? Why? CMD, blah 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 blah. Try again. Get the asset, then we close it. File descriptor. How does the asset get loaded though? Asset, file descriptor, close. Hold on. I'm having second thoughts here. Oh no, now I'm really lost. Hopefully copied the right thing. 'Cause there's two of these things and the URI looks like the other one. Create asset audio player. He creates the asset. How does he transfer it over? Asset descriptor. Oh, from this FD, from the asset descriptor. Before doing the close, you can file as asset file descriptor. Yeah, okay, so we're doing it correctly. Just making sure. I'm starting to get a hang of this a little bit. What's going on? Okay, why is Clang pissed? Okay, let's clean the project. Clean. Let's go check our header files. I know what the problem is. We forgot to do this. We forgot to put in CMake CMake lists.txt. The fact that we're inserting the audio library. Ooh. Made it such a common idiot mistake. Everybody will make this mistake, I think. 99% of people. So, I'm going to go check the size of my app, and then we will add this to CMake and compile it. I can show it on screen and how I do that. It's always interesting. It's like a... Alright, so when I'm in there, what I do is I think I hold down the circle, the middle. Oh no, not Gemini. We don't want to duck Gemini. How do you do it? You press the square, then you go up to the top of the app, click on that. We're at 16.98 megabytes, so 17 megabytes roughly. Let me pull that and show it. Alright, so I have to hit the little square, not hold it, but just click it. So I click it, and then I have to scroll back to it, hit the top of it, and so I can see the storage. And that's what my APK size or bundle size is. Well, there could be a technical differences, but whatever. Okay, so what this does is in CMake files list in target link libraries, and you have to put OpenSL after log. They put it after log, but I bet you could put it before log. And this is our project and target link libraries. So we have GL3 Android after log. We could also exclude log and see how much we can get, but who cares? Just keep log. Because if some user runs it in release mode and they have some sort of issues, it's like you still need a little bit of debugging even on a release version, I believe. Alright, so now we sync. Now we should be almost good. And on jump function we'll play, and we gotta load the sound. Make sure we load it like we load it once and create texture. Alright, build successful. That's only for the project, not the binaries or precompiled binaries or the stuff. At least the project didn't fail. Now we've got to build the project itself, which sounds confusing, but alright. No. That looks scary. Whatever this thing was. Uses or overrides a deprecated API. Huh? And I think it crashed. I think it did crash. Why? Yeah, it does crash. Damn it. Alright, this takes it a minute for it to start to debug up. So we're not loading in the other 3 things that the thing has. Ooh. So the path is just like that. I have to drill down and see what stupid thing I did. I did something bad. Maybe I copied the wrong thing. Or didn't copy something. Alright, so we're in the debugger. It's already good. So that worked, that worked, that worked. Evaluating. Okay, so we do have some file. Nice. Alright, so we got an audio source. Output mixer. Sync. Create the audio player. Cross your fingers. Registers SP. Pretty cool how it shows you the disassembly. Right. Okay, so we do all that. Create sample buffer. I think we need to create a sample buffer. Do we create a sample resample buffer? Yes, we do. But do we really create it? What is this? Clip playback. So it crashes on player object, FD player object. We're not instantiating the player object. Okay, we gotta go see what the difference is. No, just tell me what to do. So I believe all it is just some other NIT function. It's probably something like this. It's select clip, I believe. Select clip sets the buffer. Or something. Alright, so Oh, I did it wrong. What I should do, just to speed this up, is just go take a break and put breakpoints everywhere in this thing. At the beginning of all the functions. It's probably the best place. Alright, let's try this again. Alright, so it did break here where I initially put. So engine, yeah, so engine has a pointer. I don't think I had engine pointer over there. This doesn't have a pointer because it gets it. And then it generates the engine pointer. Line 200. Get interface. Create engine. Just saw it. Oh, it is right here. What is this function? Yeah, it is create engine. So when does he call the J9 method to create engine? This is the stupid part about using mixed Java code to show native code. It's like, what if you purely wanted to do this in native code? It's just so annoying. You have to like rewrite half of what they wrote. The version is better than this. What if it wasn't? Oh yeah, here they ask for permissions. And then you gotta rewrite this and dir. Get assets. So on create, obviously. So this is what I need. So I need to create engine method, create sound engine method to be exactly precise. Alright, ING sound. We could put it in here, shove it in there, but IT sound will load the sound. Alright. Stop this for a second. I don't know what the difference is. Stop. Oh, I had two apps running in debug mode? That's crazy. I would think it just would destroy Android. It used to, I think, destroy Android Studio for attempting something insane like that. I guess it works now. Shader sound engine. What's the difference between audio and sound? One's a wave, and the other one is decibels. No, I don't know. Alright, this is dumb. Oh, it ran. Okay. So it might freeze when I do this, but we'll find out. We'll try to later fix it, but for now we're going to embark into an emplacement back journey. Emplacement back. Alright, where's our jump code? So this is the difference between purely native and the native samples Android gives. They're stupid because they're not purely native. They're obscured by Java. And because of that, it's like people like take a look at this one time and they're like, yeah, it's time to go on Unreal Engine. It's never gonna get done. Play sound, play our sound. Yeah, so this should be launched off onto a thread and all kinds of little things. But we're just gonna record what's about to happen. So when we hit the jump button, which is I think up or X, I don't remember which one it is, when the character moves up. We saw it in the last video somewhere. It works, it worked, it worked, it worked. And it just repeats. And then comes part 4, fixing all this. I don't think it records the audio. Here, I'll make a video. The next part will be, I guess, fixing the repeat and adding more sounds, and maybe part 5 will be channels, or maybe it won't be in part 5, it'll just be sometime later. But audio is like the second component of all games, and nobody wants to work on them. I'm on the wrong way. Wi-Fi, sorry. When I go on the other computer, I go on the other network, so I could also use Camo Studio, and it's also like a safety feature not to conflict. Oh wait, this doesn't have any audio anyway. Because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Hello, I'd like to eat burgers because my farts are not good enough. Alright, so we added 17 megabytes to 59.78. My brain is too stupid to do the math, but it's 43, I believe, is the answer. The coprocessor math unit in my brain. That's what that says, but we'll just do it on the calculator. 60 minus 17 equals 43. Yes, my arithmetic math calculator is okay.